Hello and welcome to a new video on my channel. I had a previous video up on Consul and getting started by installing it on Kubernetes and working with the key value store and services. Then I had a second video as well about playing around with Consul Connect, sort of service mesh features of Consul, but on the local machine. So this time we'll take a look at the Consul Connect features on Kubernetes. And what we're going to do is going to be quite practical. You see it in front of you right now, the diagram you see there. So basically we will use the same containers as I used in the video demonstrating service mesh on my local machine. So we'll have a real-time app, which is just a web app written in Go that presents a user interface, and that web app has to connect to a Redis backend, a Redis database. And we would like to secure the traffic between the web app and the Redis app by using mutual TLS, and also use, for example, the intention features of Consul to allow or deny the traffic. For example, I might deny by default all traffic, and then I allow the traffic between the different services that need to connect to each other. So how does this work? Well, in the difference with what we did on the workstation, there we use the Consul Connect proxy, which is a proxy that you can use for testing on your local machine or even in other environments. On Kubernetes, something like Envoy should be used or will be used as a sidecar that will be hosted next to your container in the pod. So when we deploy our real-time application, we'll have to modify via annotations. You see that later. Via annotations, we will give the instruction to automatically inject the Envoy container in the pod. So that means that when we deploy our real-time app, Envoy will be configured as well. The same is there for our Redis pod. So we deploy the pod as normal via a YAML manifest, but by using the annotation that you see here, we will inject the Envoy container in that pod as well. What will happen then is, of course, what will happen in that case is that there will be services registered. So there will be a service registered for this real-time app. There will be a service registered for the Redis app. And you can control the name of the service the way you want to. So this basically means that whenever a connection needs to be made, these Envoy proxies, they know what they need to do because they can use the registered services to find out where to connect, to what port to connect, to what IP to connect, and so forth, right? Now, of course, we will need to tell the system, in this case my real-time app, we will need to tell him, look, instead of connecting directly to the Redis application, you will need to connect to the Envoy proxy. And we also need to tell my real-time app what the local port will be that needs to connect to. So the real-time app will connect to localhost, in this case 6666. And then, of course, this component, the Envoy proxy, needs to know how to forward this. That's done again with an annotation. So here you see the annotation we have to configure. We have to configure the upstream. The name of the service is here, which refers to, of course, the proxy here. And then 6666 is the local port that we are going to use. So let's check out how this works at the Kubernetes level. Now, before I show you how we configure our application, you need to, of course, make sure that the injection of these proxies is enabled. If you watched the previous video, you know that we installed Consul using the Helm chart, and we installed the Helm chart by using Pulumi as well. The values you see there in front of you, they are quite important. So connect inject needs to be enabled. Otherwise, the injection annotation that we add will not work. For the service mesh to work and all the functionality to work, you also have to enable the client. So client enabled true, client gRPC has to be enabled as well. The Helm chart also makes sure that all the Kubernetes integration components are correctly installed as well, that listen to the annotations that you add to your to your application manifest. So make sure when you install Consul that you use these values. Otherwise, of course, the injection will just fail. Now, Consul was already installed on my system here, and here you see the default services that have been that's installed. First of all, the Consul service itself, and then all the services that were discovered at the Kubernetes level. If you watch my previous videos, you also know that the application I'm using requires a key value pair, Redis pattern set to a channel pattern to subscribe to. That's not too important, but we need that key value pair here as well. So for the rest, nothing special about this Consul deployment, right? Good. Then we can check what we have to do to deploy our application. And I'll just clear this out here and CLS because we're in the command prompt. And what you'll see is the following. If I switch to my YAML file, yes, so indeed, I made a YAML file to demonstrate the connect functionality. And this YAML file, if I enlarge it a bit, let's do that. So we enlarge the key size, the font size a bit. And then we can take a look a bit more closely. What do we have here? Well, first of all, we deploy Redis. Nothing special, not a Redis cluster, just a single deployment of Redis in this case, to keep it simple. But important, we need to have this Envoy proxy injected into the Redis pod. And it's very important that you put the Consul annotation, that you put that into the metadata of your template. A common mistake is to actually put the annotation in the metadata of your deployment, and that's not going to work. In this case, we only need to have the Envoy proxy. That is all. It will be injected due to this annotation. What will happen automatically is that Envoy proxy, when it's installed, you will look at the name of your container or containers. In this case, I have a Redis container here. That will be registered as a service at the Consul level, right? So that service registration is automatic. And that's also how other systems or other components in the cluster will be able to connect to Envoy that's in front of this Redis pod. So that's the only thing we have to do at the Redis level. So if you look at the diagram we had earlier, that will make sure that Envoy gets installed within that Redis app pod. Nothing too special about it. For the rest, my deployment spec is the same. There's nothing different than at other times. Of course, we have our deployment of the real-time app as well, where I ask for 3 replicas to be deployed. That will also mean I will have 3 Envoy proxies to be installed in every pod here. And naturally, we have to also inject the the Envoy container. And that's important. We have to define what's the upstream here. So this app will connect to to Redis. Well, of course, then we define the upstream to be the Redis service, because as I explained earlier, that's the service that will be registered at the Consul level. Then the port, that's not the remote port, that's the local port in this pod that my application, so my real-time app, will have to connect to. So of course, in my code, I'll show you the code in a moment. In the code, I will need to connect to this one here, so that the Envoy proxy knows, okay, that's a connection, and that connection, I have to forward this, I have to connect this to the Redis Envoy container that's living in that other pod over there. That's basically all there is to it. In this case, my application can use an environment variable, so I could do this here because I know I have to connect to localhost 6666. There's also another way that you can connect by using environment variables, and I'll show that in the Go code. So that's actually all that we have to do here. I also have a service as well that enables or that makes this service, that makes my real-time app, the real-time app, available via a load balancer IP, and I also have to have session affinity here because that's important that the client keeps on connecting to the same pod and is not connecting to different pods all the time when a new connection is made. Great, that's it. So I'm going to deploy this one here. I'm going to make sure that I'm in the correct namespace. So Kubernetes, this is the Kubernetes plugin for Visual Studio Code. Yes, we are in the default namespace. Let's just do it there. And I'm going to run kubectl apply -f real-time YAML from the connect folder. So this one will be applied. Let's do that. And my deployment of Redis, my deployment of the real-time app, and so on will be created. This is going on as we speak. So if I'm checking my workloads here and I'm checking the deployments and I open them up and refresh them, what you'll see, of course, now they're still red. Why? Well, for instance, you'll see that and now there are multiple containers being run. For example, the Redis app also has an init container, but also the Envoy container will need to be there. My real-time app, it's the same thing. Normally it's only one container, but now there will be 2 extra containers added to it, and that's all due to the injection that we do, as you have seen in the real-time YAML. So I'm giving this one some time to come up. So Redis app already is now completely running. So the 3 containers within the Redis pod are running, and then it shouldn't be that long until my real-time app containers turn green as well. So it takes of course a little bit longer to deploy the real-time app containers or pods. Why? Because of course the injection needs to happen and the Envoy proxy will need to be injected in those pods. So normally everything should be green now, and if I follow the log, I should see this app. Of course, now the logs, I can select what logs I want to see. For example, do I want to see the Envoy sidecar logs or my main container logs? My main container has, you can see it here, logged out that he retrieved the key value pair and he did a connection, a correct connection in this case, to Redis. I sent a ping to Redis and Redis sent a pong back. This connection should now run or work over these Envoy proxies, and end-to-end the connection should be or will be encrypted by mutual TLS. Good. This is all working, but of course, what did we do inside the container or the application code? How did it connect to the actual instance of Redis that he wanted to connect to? So let's go to the real-time Go application. Let's make it a bit smaller. And I'm not going to go through all the code here. So the code, of course, is using the Consul API for Go. And we have a couple of helper functions here. And basically in the beginning, we are asking for where's Consul living. I want to interact with Consul. Look at my other video on why we use this Consul HTTP ADDR environment variable. Then we connect to Consul based on the address that's in this environment variable. Then we get our key value pair via this helper function here. I'd like to have the Redis pattern. Otherwise, we have a fatal error if that pattern is not set. And then, important here, I'm using environment variables which are set automatically by Consul, by the Consul components in this pod, that tell me, okay, retrieve the service host, which will be in this case localhost, of course, because we connect locally to the Envoy proxy, and give me also the service port that was defined. So if you remember this, we actually defined this in our real-time YAML. If you look at it here, you can see that we specified this. So indeed, this will be Redis and then 6666. So by using these environment variables that you see here, we get the correct connection here. Yeah, and then we just say, okay, give us the environment variable. Now, in my case, because the Redis host environment variable was set, that environment variable will take precedence. But I just mentioned this here, showing this here, that you know that these two environment variables are set automatically by the system, so that you know you can use those in your code to connect as well. So that's not too special there. Now let's see if our application really works, but for that to work, I need to, of course, make sure that I have my that I know what service I need to connect to. So let's go to the services for real-time app. Let's click on that and let's find the public IP that we use. Let's go to the browser. Let's go to that address. And yeah, indeed, the application is shown here, so that that works, right? Now, again, to demonstrate that we are using Consul here, what I'm going to show you is this intention. So with intentions, you can specify what services are allowed to connect to each other. In this case, because I didn't specifically set all connections are denied, yeah, they're all allowed by default, so I don't have to do anything. But in a situation where you deny everything, you of course have to specify that in our case, the real-time app needs to connect to the Redis app, so to speak. I'm gonna now turn this around and deny it and create this intention here at the console level. Now that doesn't really have an impact on the existing connections. We have existing TCP connections open. I'm not seeing those ones to be reset. Maybe that takes some time. Maybe you have some information about that. Just let me know. But you will clearly see that it doesn't work when I delete one of the pods here. So I will just delete one of the pods, delete, and done. This pod will now restart, because my deployment specifies I need 3 replicas. But due to the intention, or because of the intention, it shouldn't turn green. And if we are looking at the logs and we follow the logs, you can clearly see that the logs mention this error here. If you watch my previous video where I demonstrated this on my local machine, it's the same error. So there's a connection, they try to make a connection, but then, yeah, it's really rejected by the other side. And in this case, this results in a bad pub-sub connection in this case. Indeed, we cannot subscribe correctly to Redis, and that's why he gives this error. So this is a Redis client error in this case, which is popping up. So you see that the intention is clearly working. So for this to actually work, I need to make sure that I allow the traffic explicitly now, or remove the intention, and then I can delete this pod again. I will delete the pod. It will come back up, and it will of course turn green because the connection is now allowed again, and it's working properly. So that's why you see now that this configuration that I talked about earlier is in effect. So we have this connection between the real-time app and the Redis app using the Envoy proxies, and then having this MTLS encryption here, and the intention, you've seen that with a deny, they cannot connect to each other. So that's basically it. In short, how you do the service mesh functionality, or the basics of that at least, in Kubernetes. It's all made relatively easy due to the fact that they can be injected. That's similar to other service mesh solutions out there. And the only thing we had to do was to make sure that we have the correct service upstream definition there, and then everything is working nicely. Maybe one more thing here. It's important to note that by default, if I'm binding this 6379 binding to everything on my pod, it's still available. It's actually still available, that direct port. So I would need to bind this to localhost, and that would mean that I can only actually connect via the Envoy proxy and not directly to the Redis app. I didn't do that here. So if I wanted to do a connection to port 6379, that would actually still work in this case. And it's a perfect scenario. You could have Envoy deployed already. You're going to migrate to it, but in the meantime, you leave open the existing unprotected connections because your app still needs to work in this unprotected state, so to speak. That's a possible configuration. Okay, that's it. Thanks for watching and see you some other time. Bye bye.